think we were here where we talked about them, but we hadn't done anything yet, right? Okay. So we're going to take this blank space, chop it into, oh, yeah, okay. Yeah, and then we're going to go back up to the other ones. There we go. So we have, actually, I need that. Here's the question that's not going to be worded very well because I don't want to have to write the whole thing out. So diagonal, we'll abbreviate, diagonal of square, okay? That's what that means. Diagonal of square is 7 times the square root of 2. Find perimeter of the square, but we'll just put perimeter. We know what the question means. It would be worded much better if it was on an official anything. But. So, you know, the first thing I want you to do, which is draw a picture. And is a square a rectangle? Yes, a square is a rectangle because it has 4 right angles. What makes a square more special than a rectangle? It's equilateral. Very good. Look at you using the fancy words and everything. All 4 sides are congruent, right? And we have 4 right angles, but we don't just have to draw that in. The diagonal, which goes right there, or the other way, doesn't matter, is 7 times the square root of 2. All right? So look what you get when you draw in the diagonal of a square. This is a right angle. These 2 sides are congruent. You get an isosceles right triangle or a 45, 45, 90 triangle, right? So then we can go to our reference materials here and get what we need for that. Of course, it's right above us on our notes right now, but and we can label this to say that this would be S, this would be S, this is S times the square root of 2. Once again, those are not 5s, they are S's. Not good S's, but they're S's. So if this is true, what does S have to equal? 7. Everybody understand where we're getting 7? If 7 times the square root of 2 equals S times the square root of 2 is 7. So a side length is 7, which means they're all 7. They did not give me the formula for the perimeter of a square, but I actually don't need a formula for perimeter of anything. We just add them all up. So 4 times 7 is 28. I really don't think any of the computation with special right triangles will be complicated. It's usually very simple because they're just trying to see if you understand the relationships and how to label things and things like that. What I have in orange here came from this right here, S squared root of 2. Okay, I'm using just labeling from there. Any other questions? All right. So then, here's our next one. We have a 30, 60, 90 triangle with long leg of 10, and we're going to find the perimeter of this one also. Okay. That is an example of what a question would look like. That's a very good question. Yes, absolutely. That's a very good question. It will either have a picture on it where the angles are there, so you have to recognize it is. It will literally say 30, 60, 90. For these, it could either say 45, 45, 90 or isosceles right triangle. Yes, so these random things that we're kind of putting in, it was because there were so many different types of examples that I was pulling from actual SAT stuff that I didn't know which ones I wanted to do. So yes, mine are worded terribly, but it's basically the same wording that would be there. All right, so the first thing we're going to do, draw a picture. Like I said yesterday, most of my right triangles all look exactly the same. It's fine. I got a right angle. Where I put the 30 and where I put the 60 really doesn't matter at all. Okay, you just pick one and then we label accordingly. So we got 30 and we got 60. Now, even though this type of thing is given to you, bless you, on your reference materials, you still have to be able to know how to figure out which is the long leg and which is the short leg. Hypotenuse is the longest side, but you have a hypotenuse and 2 legs. Hypotenuse is the longest side because it's across from the biggest angle. So the smallest angle is across from the shortest side. So this would be the short leg, this would be the long leg. Does that make sense to you? And they told me the length of the long leg is 10. So this is 10. That's how I know where to put it. Has to be across from 60. If I had to put my angles the other way, it would be somewhere else, and that's fine. Then the other thing is, and when you get to this little pattern off of your reference materials, you have to make sure you're putting it in the right spot. So a good thing to do, I think, is before you even look at that, is make sure you know where the short leg is. Across from 30, that's your short leg, so we're going to make that S. Then when you look at your reference materials, which we do have right in front of us right there, we know that the hypotenuse then would be 2S, and the long leg would be S times the square root of 3. Okay. Everybody okay with everything we've done so far? Then when you do that, you have set yourself up a little equation here, because basically we need to know what S is to figure everything else out. This basically says to me 10 equals S times the square root of 3. So if I do 10 equals S times the square root of 3. If I need to figure out S, I need to divide both sides by the square root of 3. So S is equal to 10 divided by the square root of 3. So one thing we are not going over right now, because you have an SAT tomorrow, is how to rationalize the denominator. If you know how to do it, you're confident, do it. But I'm not even going to do it up here because I don't want to confuse anybody or lose anybody. You have access to a calculator for the whole thing, so I'm just going to tell you how to handle that with the calculator when we get to that point. So here's what we have. This is this side length. This side length is 10 divided by the square root of 3, which is S, right? Hypotenuse is 2S. So that means I have 2 times 10 divided by the square root of 3. Don't make up math because you have a fraction and it has a square root in it. The rules don't change. You just multiply straight across. That gives you 20 divided by the square root of 3. And that's your third side length. Okay. Everybody okay with all that so far? We want to find the perimeter, so we want to add them all up. I'm going to add 10 plus 10 divided by the square root of 3 plus 20 divided by the square root of 3. I'm not going to be able to combine all 3 terms because this one is different, but these have a common denominator, so I can combine these two, and I can get 10 plus 30 divided by the square root of 3. Now, when you look at your answer choices, I would be shocked if all of them started with a 10 plus something. I would imagine that that number would change based on whatever mistakes they would think that you would make. So you should be able to eliminate some. You can eliminate the ones that don't start with a 10. And then of the ones that are left, you can either rationalize your denominator if it makes sense to you, but you can type this into the calculator and then match it up with your answer choices. I mean, I know you all know how to do that and finagle that stuff. We all good with that? We good so far? All right, let's go up here. We got 2 more 30, 60, 90 triangles to do before we get back with some trig stuff. All right, so we have an isosceles right triangle with perimeter of 8 plus 4 times the square root of 2. We're going to find a leg. And because it's isosceles right triangle, we don't have a long leg and a short leg. They're the same. What's another way to say isosceles right triangle? 45, 45, 90. It can be referred to as either way. So I'm going to draw my triangle. I know it's a right triangle, and it's isosceles. Even if it doesn't look to scale, once you mark them that they're congruent, they're congruent. I have the perimeter, but I'm trying to find the length of the leg. So I'm going to take my pattern that I can label on here and do that. This is going to be S times the square root of 2. And I don't even have like a long leg or anything to put on that, right? But if I was to find the perimeter strictly with variables, I would do S plus S. Actually, before we do that, so I said earlier today that once you get that on there and you look at what you have, you may not feel you need to do anymore and that you know the answer, and that's fine. And somebody very, very confidently from a class that never talks to me, so this poor child will never speak again, but was like, yes, and yelled out the wrong answer. And I was like, well, thank you for participating, but no. So let me show you what you can do. So we're going to just literally going to add all these up. Plus s times the square root of 2. So when I do that and I combine my like terms, I get 2s plus s times the square root of 2. That makes sense, variable-wise? And so that's what I get from here. And then this is what we have here, 8 plus 4 times the square root of 2. And maybe now, doing any other work, what do you think s would have to be? 4, y'all are afraid to say anything now that I yelled out the wrong answer. Be 4, right? If this part is s squared root of 2, it's 4 square root of 2. 2 times s is 8, so s has to be 4, and that's the length of the leg. Okay. So sometimes when you label it, you can recognize that stuff without writing anything else down. That's fine, because like I said, the work shouldn't be, brain numbing. Like it's really just do you understand how it all works together. Okay. Questions? Okay. 8 was what he yelled out, by the way. He's very proud of himself. I'm sorry, no. All right. Here's the next one. So we have an equilateral triangle. Oy, doesn't look like a triangle. With perimeter equals 48 inches. We want to find the height. Okay. So tell me what you know about an equilateral triangle. Okay, all the side lengths are equal because that's what that means, equal lateral, equal sides. So when I draw my triangle, I'm going to try to not make it look like the rest, but it still doesn't have to be perfect and pretty. But all 3 sides are congruent, right? And I am looking for the height. So not only are all 3 sides congruent, but what else is all congruent? The angles, good. So I have 3 angles, which means one angle would be how much? 60. If there's 3 angles, it's all good. So this would be 60. Everybody good with that? So what they want you to connect this to here is they want you to realize that you have a 30, 60, 90, actually 2 of them, living inside that equilateral triangle. You need at least one side length to be able to do something with. Well, I can find a side of the triangle. If the perimeter is 48, what do I do with this number to find a side length? If they're all congruent. 48, and what do I do with it? Divide by 3. 3. And I get 16. Now, should we be able to do that without a calculator? Yes. Do you have access to a calculator? Yes. So should you do 48 divided by 3 on a calculator? Yes. Okay. Don't be trying like, oh, look at me, I can add and subtract. Great, but you might mess it up, so use your calculator. So you got 16. Then the next thing I would highly suggest, and I would do for myself, because my picture isn't even big enough to do what I need to do, and most of yours probably aren't at this point, I'm going to take this triangle here that I created and redraw it next to it just basically by itself, so that it's not inside the equilateral triangle anymore. This is 16, this is H, this is 60. And whether you label this as 30 or not, but it's 30. So I have a 30, 60, 90 triangle. Before I even look at the patterns that I have and the labels I would put on there, I'm going to figure out where the short leg is. Is the short leg what I have labeled as H? No, because this is across from 60, so across from 30 would be my short leg. I'm going to get an S on there. And then I'm going to go look at my reference materials so I can make sure I put the right things on the other ones. This is 2S, and this is S times the square root of 3. So if that is true, and 16 equals 2S, what does S equal? 8. Yeah, 16 equals 2S, so S has to equal 8, which means H is 8 times the square root of 3. Okay? We all right with that? What questions we got? All right. Now we're going to go back to some trig stuff. So grab your second sheet of paper, which we can put on page 43. Oh, I'm sorry. What's the question? Oh, I'm so sorry. Yes. The second piece one? No. There you go. All right. Before we get into what this page actually even says, we're going to use our blank space here to do a couple other things. And these two that we're going to do before we get to what this paper even says is what I feel like I think it threw some people off that totally understood their trig just because they seemed like weird questions. So I thought we'd do a couple of those. Here we go. So I'm going to give you a triangle. And this is A, B, C. And then we are going to label our triangle with X, Y, and R. And then what they want us to find is the sine of A times the sine of, no, that makes no sense. I mean, I guess we could do that, but that's not what I was trying to write. Times the tangent of A. And this was before we started going over all this. Somebody was working in another class on it. And I think it's because you're so used to setting them up with values. Like if I'd have put numbers there, it'd be a piece of cake. We throw in variables and like your brains fizzle out sometimes. I'm not sure why. So we can't be afraid of this stuff. Both of these have to do with angle A. So I'm going to label according to angle A. This is the hypotenuse. This is the opposite side. This is the adjacent. So we know that sine is opposite over adjacent. So I use the labels that are there. Opposite over adjacent would be y over r times the tangent of A is opposite over adjacent. That would be y over x. Does that make sense? I'm literally just setting up the ratios. And they wanted me to multiply them, so I'm going to multiply them. And that gives me y squared over r times x. Oh, absolutely, yes, 100% SOHCAHTOA, yes. That's all it is. But it was weird because, I guess because it was multiplying, because it was variables, people were like, I don't know what to do. Literally just do whatever it says. It's not that big of a deal. All right, so then over here, I'm going to say that we have triangle RST is a right triangle. Angle S is a right angle. No question yet, but we're going to draw and label and then do the question. Okay, so they're telling me I have a right triangle. They're telling me which angle is the right angle. So I'm going to draw my triangle. Then I'm going to label. So my right angle, they told me that was S. Where R and T are, totally up to you. Because that's a good question that I always get, which was, how did you know to put R? Well, you know how I knew where to put S, right? How do I know which one's R and T? It doesn't matter, because as long as I label correctly after this, it'll be fine. So I'm going to put R here and T here, just because it really doesn't matter, and a decision had to be made. Then, this is what we are going to find. We're going to find the sine of R, the cosine of R, and the tangent of R. Then we're going to find the sine of T, the cosine of T, and the tangent of T, and only label once. I'll tell you what I mean when we get there. So I'm going to start with the R's. Since I'm going to start with this first column, I'm going to label everything according to angle R. This is the hypotenuse, this is opposite, this is adjacent. Now, not only do I not have numbers on this one, I don't even have variables like X, Y, and R. So this is another little reminder about some geometry stuff. I know that sine is opposite over hypotenuse. So opposite over hypotenuse. And I can't just put O over H. That wouldn't make any sense. But this opposite side, I can name ST. You can name a line segment with the two endpoints. If this was line segment ST, there'd be a line above it, but without the line, it means the length of line segment ST. So ST over TR. Another reminder is that I could have named that ST or TS. Doesn't matter in this particular case. So if you write something down like that and this isn't there, but TS over RT is, that'd be totally fine. This is the same thing. Then when I go to do cosine, that's adjacent, which would be SR over the hypotenuse, which is TR. Oh, and one thing I was going to remind you that you can't do is in this first one, you cannot cancel the T's out. Here, I cannot cancel the R's out. Like, that makes absolutely no sense because that's not what's happening, right? And then tangent is opposite over adjacent, so ST over SR. And then I said we're only going to label once because we only have to. Now, in the grand scheme of things, if you needed to label it again, it would be 100% okay. And by label again, I mean, if I'm going to do angle T now, I would need to label my triangle opposite and adjacent according to angle T. But one of the things we talked about yesterday was the sine of this angle is the same as the cosine of this angle. So the sine of R is the cosine of T, ST over TR. Because all that's happening is the opposite and adjacent switch. And then the cosine of R is the same as the sine of T, and this is SR over TR. Okay. Nathan, you getting all this? Then for tangent, tangent of R is opposite over adjacent. So basically the tangent of this angle is equal to the cotangent of this angle. Didn't ask me for cotangent, but they're just reciprocals. So instead of opposite over adjacent, it would be adjacent over opposite, which would be SR over ST. Okay, so we've got, just wanted to remind you, you could also name it with side links like that, because I did see a few that were similar to that. Exactly, that's it. That's it. And it asks you some other things like, could ST, what would ST be equal to? Well, the length of ST would actually be equal to the length of TR times the sine of R if I multiplied, right? And as long as you understand how to name with the side links, you can figure out the other relationships. That's just the names of the side links, yes. And because I did see more than one like that, I was like, we better talk about this again so you don't get confused about that stuff. We good? All right, so now is where I'm going to start pushing some of you way out of your comfort zone, because for some of you, some of the next stuff we talk about will be brand new, but that's okay. I'm not going crazy in depth because I'm going very fast, but I do feel like the little things I'm touching on, if you get a question and you've at least heard something today, you might be able to reason your way through it, because this is a reasoning test. And also, if you get a question that is has anything to do with some of the stuff we're about to talk about, this is an adaptive test. The first question that relates to this should be super easy, because they just want to see, do you even have any clue what we're talking about? And then they would progressively get more difficult. So I'm telling you that to say, don't overthink it, especially if it's one of the ones you saw. Okay, just take a deep breath, think about some of the things I said today, and maybe it's still fresh enough in your brain that you could get through something. Okay. All right, so I'm going to not really show you the words up there. I'm just going to tell you some of this stuff. One of the things that I am pretty sure was also in geometry, at least I taught it when it was looking at angles in the coordinate plane. Probably didn't do a whole lot with it, but know that they exist there. This is in standard position. The only way you would see an angle in the coordinate plane on the SAT would be in standard position. Even in pre-cal, we pretty much just look at them in standard position. But you start an angle. This is what's called the initial ray. It starts on the positive x-axis. This is 0. So it's like this. And then the other side rotates around. We rotate around here to the terminal side. And the terminal side here is in quadrant 2. So this is 90 degrees. We go a little bit more. We'll say it's 120. It's really probably more like 135, but nobody expects you to guess. I'm just labeling. Now that I labeled it 120, it's 120. And that's a positive 120 degrees. Now this is what maybe some of you don't know. You can have negative angles. Am I going to have a negative angle measure in a triangle? No, that doesn't make any sense. But if I start here and instead I go clockwise and go this way, this would actually represent a negative 90 degrees. So again, at least as long as we know we got positive and negative and which way to rotate to know which is which. Here's the way that you can remember that. You've known what the quadrants are forever. And if you are like most people, including myself, before I really understood it, I would think, I don't know who labeled them this way, and I don't know what they were thinking, because we read left to right. Why it starts with 1 there made absolutely no sense. Until you get into the deeper math and understand it has everything to do with these angles. We start here at 0. We go through the first quadrant, then the second, third, and fourth. It's the quadrants you rotate through when you start here at 0. So knowing what the quadrant numbers are, think about when you rotate through the quadrants, that's positive angles. So counterclockwise is positive, clockwise is negative. Okay? And again, we'll just kind of stop there with that in case anything comes up with the angles. All right. Now, we talk about that stuff in the coordinate plane so that we can get to triangles in the coordinate plane, which again might have been touched on in geometry. It's really more of a pre-cal thing, so I'm not going to get too deep into it. Just the highlights here that I think you could reason through without making anything super complicated. Remember that we are starting here. That is our initial ray. If we rotate to get point P here, we have made this angle theta right here. Then we can put a triangle on the coordinate plane, but I want to make sure you know how the triangle is put on there so that you can do everything correctly. When you do that, you have the radius, because it goes from the center to a point on the circle. And then let's think about how we would plot point XY. You've been doing that since like, I don't know, 6th grade. You've been plotting points. We start here. If this point is XY, I'm going to go to the right X units, and then I go up Y units. And that creates a right triangle. Boom, right there. I'm going to show you 2 common mistakes about placing triangles in the coordinate plane or in a circle. You don't necessarily have to have the circle there. So don't draw this because I'm about to erase it. But we definitely don't do this and make this the right angle. That kind of makes no sense at all. But another common mistake that happens even when we understand things is using the radius, but making the triangle with the y-axis. That's a big fat no-no. You always go to the x-axis. All right, so this is what you can draw. You can draw in that radius. We make it perpendicular to the x-axis. And then I have another triangle here. What quadrant we end up in could matter too. That would tell us about signs. We'll talk about that. But because of this, so if this is xy, we're in the 3rd quadrant. So everything in the 3rd quadrant is negative, negative, right? So this point would be negative x, negative y. So when I plot this, when I go to the left, I go to the left that many, and I go down that many. Still x and y there. This is still r. Now the length of the sides are x and y, because length has to be positive. This is displacement, okay? Vertical and horizontal displacement. So when I'm looking for the sine of theta, right here, sine is always the y value over the radius. That's where it comes from, y value over radius. If even the first 2 years I taught pre-cal, I understood the y and x relationship, but my brain was still so wired from SOHCAHTOA that I still would, I would be forced to think of it as opposite and adjacent first, which is fine. It's kind of what I'm getting at here. If you can't remember if sine is y over r or x over r, this is theta. Opposite over hypotenuse is y over r. Where it's coming from. It's still just SOHCAHTOA as always. Cosine, x over r, adjacent over hypotenuse. Tangent, y over x, or sine over cosine. I don't know that that would really be there on the exam, but that's how the and we're going to look at the triangles a little bit more on the next page as well. Okay? You sort of with me? Remember, I'm throwing in a whole lot. Even if a tiny bit sticks, you might be able to reason through some stuff. All right. So here's this point. And what this says, this 0.34, it says the figure shows a circle with radius 5, centered at the origin with an angle measure of theta in standard position. The terminal ray of the angle is intersects circle P. I really think in their questions, it would say probably something more like the terminal ray of the angle is in the 4th quadrant, and then for you to know where that is. And It has, again, to do with the ordered pairs, because what you've known forever is in the first quadrant, all ordered pairs are positive, positive. In the second, they're negative, positive. Third, negative, negative. Fourth, positive, negative. Okay, that's something we know for sure. So when they're telling us what quadrant we land in, that we want to make our triangle in, it's just helping us know what the signs are on X and Y. So here's what happens. We have this initial right. And it says we rotate all the way around here to get this terminal side. Now that's a big rotation. Then we rotated through 90, 180, 270. This is probably about a 300-degree rotation, which is a huge angle. You can have a huge angle like that. Can you have a 300-degree angle in a triangle? No, that makes no sense because you can't have more than 180, right? But when I create this triangle here, even though I just made a 300-degree rotation, this is the angle that's made with the x-axis is the angle that I'm actually using, okay? It's always the angle with the x-axis. And so when I rotate around there, if this point is 3, 4, this point is 3, negative 4, because I don't understand why this acts like it's out of ink sometimes. What is happening? Okay, that would be 3, negative 4. There we go. 3, negative 4. So when I plot the point, I go to the right, 3, and I go down 4. So that's 3 and a negative 4 there. And again, the length is 4, the displacement is negative 4. The radius is 5. Now I happened to circle it because somebody earlier today said, well, how do you know it was 5? Well, because it told me. But if I didn't know and it didn't tell me, how would I find it? Pythagorean theorem. Good, you can just do Pythagorean theorem and find it. And so then we are asked for sine, cosine, and tangent. So sine, remember it is the y value over the radius, or opposite over hypotenuse. So we have negative 4/5. Then cosine, which would be adjacent, or x over r, 3/5. And tangent, opposite over adjacent, or y over x, which is negative 4/5. Okay. Everybody okay with all that so far? Okay, so here's the other thing I want you to see about these triangles, is that if I have this point xy, and it reflects across the y-axis, we change the sign on x, it's negative xy. I take q, I reflect it down here, that's negative x, negative y. I take r, reflect it over here, and I get positive x, negative y. And there's a whole lot of reflections, symmetry, a lot of other things going on in here. So when I create this triangle, it's congruent to this triangle, which is congruent to this triangle. All 4 of those triangles are congruent. And so if this is theta, and remember, these are all the angles that we're using, the ones with the x-axis, this is where we get our little right triangles from. Okay. So when we look at example 4, and it says, find the sine of the angle whose terminal ray intersects the circle at point S. I really think it would probably say something more like the sine of the angle, and give you some other stuff, but then say it terminates in the 4th quadrant. By terminating in the 4th quadrant, that tells you your ordered pair is positive, negative, which means your x value, which is your adjacent side, is positive, and your vertical side, or your opposite, is negative. Because then this is x, this is negative y, this is r. So when we find the sine, the y value over the radius, or again, opposite over hypotenuse, you get negative y over r. It's down there for example 4. We basically did this one on the thing. Okay, kind of see how that works? Yes, ma'am. No. Not necessarily. Like, we don't know what it is, but whatever this angle measure, I mean, this one might be 30. But if this angle is 52, this one's 52, this one's 52, this one's 52. Okay. And we just don't know what the angle is, and that's fine. I could ask you a ton of different questions and not actually tell you what the angle is. All right. So with that said, if you see things where it says like the tangent of 2 pi thirds and the cosine of 2 pi thirds, and you don't know what those things are, that's fine. Most of you haven't learned that yet. It's fine for some of you. But if you get something where it says like, find the product, first of all, what does product mean? Of what kind of operation? Multiplication. Of sine of 5 pi fourths. Oh my goodness, not 54. 5 pi fourths times cosine of 5 pi sixths. It's okay. If you're not even sure what that means, and you have no idea what they are, here's what I want you to know. Those angles are measured in radians, okay? And we're about to talk about what a radian is if you don't remember. But you put your calculator in radian mode, and you type that thing in, okay? And you don't have to know it. Like, I mean, if they're going to allow you to have a calculator, whether you've learned it or not, it doesn't matter. If they want that product, you can manipulate it using the calculator, okay? But I do want to go back up here. We are going to talk a little bit about radians, because again, that is something that is in geometry. You probably didn't do a whole lot with it, but we need to, there's something that you could be asked to do. So I'm not even going to try with the stupid sound here. This is literally more just of an animation than anything. So we are going to start with a circle. Oh, now it's playing back there. Whatever. Circle of radius r. We take the radius distance. Sorry, this is going to bug me now. And you wrap it around the circle. I'm going to pause it in just a second. It's 1 radian. That's what I was going to say anyway. Okay. So however big or small the circle is, you take the length of the radius, you wrap it around the circle, that's 1 radian. You can measure angles in degrees and in radians. It's similar to, but not exactly the same as, taking a length of something and measuring it either in centimeters or inches. Just different ways to measure, okay? One of the practice questions I saw said something like 1 radian is about how many degrees? Okay, well, I'm going to show you exactly how to find that. But if you take a look at this and have this picture in your mind, it doesn't matter how big or small the circle is, that's how much of the circle 1 radian is going to make up. Okay, so clearly 1 radian is less than 90 degrees. Would you agree with that? The radian is the red line, yes. Well, okay. Because it is a measurement of the angle as an arc length. So we're still measuring this angle, but that is the length of it. That's the way it works. So it's about 57 degrees. But either way, we need to know how many radians are in a circle. Let me see if I can talk over that guy with it. There are, so there's pi radians in half a circle, 2 pi radians in a full circle. Circumference formula is 2 pi r, by the way. That's where how all this stuff is related. So 2 pi radians, and here's the nice thing, especially if you feel like that's brand new to you. On your reference sheet, not only does it tell you that you have 360 degrees in a circle, it tells you that there are 2 pi radians in a circle. It says it weird with like arc. Just know that 360 degrees, 2 pi radians. So that will allow you to convert, because that is something that you could be asked for, and that is something that should be very easy if you know the very basics here, especially since it tells you and you don't have to remember. It tells you on the reference materials that 2 pi radians is 360 degrees, which means that pi radians is 180 degrees. Even if you don't fully understand what that means, hopefully you can do some conversions here. And if we want to convert 60 degrees to radians, now really there's, if I was teaching this in a real lesson, I would say we either multiply by 180 or 180 over pi, but that's a formula or a concept you'd have to remember. You know how to do proportions. Use a proportion. If you know there are pi radians and 180 degrees, you can say, all right, I want to know how many radians are in 60 degrees. Simple proportion, right? Then I can cross multiply 60 times pi and divide by 180. And yes, you have a calculator, but you want to be careful with this because they probably want an exact answer. So I can knock out those zeros. 6 over 18 is pi thirds. Okay? And if they give you radians and you want to go to degrees, you can do the same thing. Just set up a proportion. That's all it's asking you to do. Okay? We're all good? If it doesn't stick, it's fine. It's fine. But again, if any little bit of it stuck, if it helps anybody, then it was worth doing, and we'll be okay. All right. So another reminder before tomorrow.